This podcast is on how to find the greatest common factor and least common multiple. Let's first talk about why we learn this stuff. So for greatest common factor, it's useful for simplifying fractions. So let's look at the complex fraction 4/16. What factor does 4 and 16 both share? Well, 4 and 16 both share a 4. So we can take 4 divided by 4, and we get 4, we get 1. And we can take 16 also divided by 4, and we get 4. So by dividing 4/16 by 4 over 4, we get 1/4. And 4 is the greatest common factor of 4 and 16. Now it might be helpful to figure out how to find the greatest common factor. So next we're going to show you how to find the greatest common factor. So here we're going to use prime factorization to find the greatest common factor. Remember, prime factorization is breaking down a number into its prime factors. So 21, let's break 21 down to its prime factors. So what are two factors of 21? Well, first we have 3 and 7. Well, 3 is prime, 7 is prime, so we can stop there. Let's go to 42 now. So 42, we can break this down to its prime factors as well. We break 42 down to 6 and 7, and 7's prime. However, 6 is composite. So we need to break down 6. 6 can be broken down to 2 times 3. And now those are both prime as well. So we have all the prime factors here. The next thing we need to do is highlight the numbers they have in common. Well, the factors of 21, the prime factors of 21 are 3 and 7, and the factors of 42 are 2, 3, and 7. So they both share a 3, and they both share a 7. A 3 and a 7. So what we need to do is I like to actually split my screen here. So I like to look at it like this and say, only looking at one side, what's the product of the two numbers we highlighted? So let's only look at this side right here. Okay? What's the products of the numbers we highlighted? Well, that's 7 times 3, which is 21. So therefore the greatest common factor of 21 and 42 is 21, which means you can divide 21 and 42 both by 21. Let's have you give it a shot. All right? Let's have you guys find the greatest common factor of 16 and 20. Go ahead and pause the video now to give yourself time to find the greatest common factor of 16 and 20 using prime factorization. All right, let's start with 16. So we need to find the two factors that equal 16, any two factors. Let's say we use 2 and 8. Well, 2 is prime, so we can circle it. 8 is composite. Let's break down 8. Well, 8 can be 4 times 2. And again, 2 is prime, so we can circle it. 4 again is composite. And let's say break down 4 to 2 times 2, which are both prime. So the factors of 16 are 2, 2, 2, and 2. Let's go and break down 20 now. So breaking down 20, we need to find two factors that equal 20. 4 and 5. 5 is prime, so let's circle 5. However, 4 is composite, so we got to break down 4. We can break down 4 to 2 and 2, which are both prime. Now again, we need to go through and highlight the factors that they both share. So what factors do they both share? Well, we have a 2 here, and we have a 2 here. We have another 2, and another 2, and that's all the factors they share. So they each share 2 2's. Let's go through again now and only looking at one side. Let's look at this side here. All right, what factors do you see highlighted? Well, I see 2 2's. So let's multiply 2 times 2, and we have 4. So the greatest common factor of 16 and 20 is 4. Check your work. Does your work look like mine? Now you could always break down your 16 by going 4 times 4 initially, but as long as your prime factors are the same, you did a good job. So let's put this to use. So we need to simplify 32 over 40. All right? So we need to first find the greatest common factor of 32 and 40. Let's do 32 first. Let's break it down. What are two factors of 32? Well, how about 4 and 8? Neither of those are prime. They're both composite. We've got to break them both down. 4 would be 2 times 2, and 8 could be 4 times 2. Our 2's are prime, so let's circle our 2's. And now we need to break down our 4 because it's composite. 4 is 2 times 2. And let's circle those because they're prime as well. So the prime factors of 32 are 2, 2, 2, 2, and 2. Let's now go and break down 40. So 40 could be 4 and 10, or really any two factors you choose. It doesn't matter. You'll always get the same prime factors at the very end. 4 is composite. Let's break it down to 2 times 2. And 10 is also composite. Let's break it down to 2 times 5. And now these are all prime numbers. Let's go through and highlight the ones they share. So we have a 2, and we have a 2. We have another 2, and another 2, and then another 2, and then finally that third 2 as well. So these two numbers, 32 and 40, share 3 2's. Let's only look at half it. So let's split the screen here, and let's only look at one side. All right, we need to multiply the numbers on one side that we highlighted. So we have 3 2's, so 2 times 2 times 2, and we get 2 times 2 is 4 times 2 is 8. So it would equal 8. The greatest common factor of 32 and 40 is 8. So now what we're going to do with this greatest common factor, which is 8, is we're going to divide both our numerator and denominator by 8. So 32 divided by 8 is 4, and 40 divided by 8 is 5. So our simplified form of 32 over 40 is 4/5. So 4/5 and 32 over 40 have the same value. All right, finally we're going to get to least common multiple. So why are we learning least common multiple? Well, least common multiple is helpful for deciding which fraction's larger or greater. So 4/5 and 5/7 are hard to tell which fraction is greater because they have different denominators. We have the same denominator in order to compare numerators. So let's go through and look at our denominators. What number can both a 5 and a 7 both become? Well, a 5 and a 7 can both become 35. So let's take 4/5 and set it equal to a denominator of 35. Well, how do I get from 5 to 35? Well, if you multiply by 7. So we got to do the same to the top. 4 times 7, and that equals 28. So basically, the fraction 28 over 35 is equal to the fraction 4/5. These are equivalent fractions. Let's do the same thing for 5/7. So we need to find an equivalent fraction of 5/7, but it has to have a denominator of 35. So 7 times what number gives you 35? Well, that's 5. So 5 times 5 is 25. So therefore, 25 over 35 is equivalent or equal to 5/7. Now since we have our two yellow highlighted fractions, 28 over 35 and 25 over 35, and they both have the same denominator, all we have to do is look at the numerator to decide which one's greater. So since they have the same denominator 35, 28 is greater than 25, and therefore this fraction is greater. And since 28 over 35 is equivalent to 4/5, 4/5 is greater than 5/7. Let's practice finding least common multiple. Our least common multiple of 5 and 7, as before, was 35. Let's practice some of these here. So with least common multiple, you need to find the multiples of both 8 and 12, and find the one that's least common. So let's first write the multiples of 8. That would be 8, 16, 24, 32. And now let's go to our 12. That'd be 12, 24. Hey, and we found a multiple they already share. They each share a 24. So therefore, the least common multiple of 8 and 12 is 24. Now that's not the only way to find the least common multiple. Another fun way is using prime factorization, as we kind of did before, but with a little twist. Let's break down 8. 8 could be 2 times 4. 2 is prime, 4 is composite. Break it down. 2 times 2. And now, on to 12. Break down 12. 12 is 3 and 4. 3 is prime. 4 is composite. Break it down. 2 times 2. And now what we need to do is, since we have all prime factors, is just like before, let's highlight the ones they have in common. Well, we have a 2 and a 2 and another 2 and another 2. So how do we decide what the least common multiple is using this scenario? Well, what you do is you basically take and you look at your 8 and you say 8 does not match the 3. 3 is not shared between the 8 and the 12, so all you do is do 8 times 3, and you get 8 times 3 is 24. You can also go the other way as well. What factor in 8 is not shared with the factor in 12? Well, that one would be this 2 right here. That one's not highlighted. That one's not shared. So you could try 12 times 2, and you also get 24. So you could use this method to also find the least common multiple. It's your turn now. Please try to find the least common multiple of 14 and 48. Pause the video now to get to work. Alright, let's check your work. If you used the multiples of 14, actually let's skip this problem. Let's try it with prime factorization. So let's break down 14. 14 is 7 and 2, which are both prime. 48, we could say 24 and 2. After 24 times 2, we need to break down 24 to 8 and 3. We should circle a 2 because that's prime. 3 is also prime. Let's break down the 8 to 4 and 2. 2 is prime. And then finally break down the 4 to 2 and 2. Let's go through and highlight the ones they share. Well, really the only factor they share is a 2. The only factor they share is a 2. So therefore, all the other factors they do not share. So that's why I chose the prime factorization method, because now all we have to do to find the least common multiple is do this problem right here. What is 48 times 7? Well, 48 times 7, 6 carry your 5. 28 plus 5 is 33. So the least common multiple of 14 and 48 is 336. If you want to do more math, you could check it by doing the opposite. So again, they both do not have in common. I'll highlight these green. They don't have this 2 in common, this 2 in common, this 3 in common, and this 2 in common. It's similar to how they did not have that 7 in common as before. So if we wanted to check it using the other method, we could go 14 times 2 times 3 times 2 times 2. All right, let's check this out. So we have 14 times 2 times 3 times 2 times 2. Let's solve it. That's 28. That's 6. Let's just bring down that 2. Let's multiply these together. I'm going to start with the easier problem over here. 6 times 2 is 12. Then bring down the 28. And finally, 28 times 12. We'll do that work over here. 28 times 12. 16. Carry your 1. 2 times 2 is 4 plus 1 is 5. 0 as a placeholder. 1 times 8 is 8. 1 times 2 is 2. Let's add these two partial products together. 6, 13, carry your 1. 1 plus 2 is 3, so 336. That's one reason why I enjoy the prime factorization method, because if you were using the multiples of 14 and the multiples of 48, it would take you a long time to get to 336. Now let's put this to use. We got some easier problems here. What is the least common multiple of 9 and 4? Well, I'm going to use the multiple method this time. So my multiples of 4 are 4, 8, 12, 16, 20, 24. I'm going to do my multiples of 9 now. 9, 18, 27, 36. No matches yet. I probably should go up and continue off my 24 here. So 24 plus 4 is 28, 32, 36. Hey, there's our match. It's 36. So 36 here and 36 here. So the least common multiple is 36. So what we need to do is make equivalent fractions with a denominator of 36. So times something equals 36. That'd be times 4. So therefore 7 times 4 equals 28. So 28 over 36 would be our equivalent fraction. Let's go over here to the 4 times something equals 36, and that would be 9. So therefore 3 times 9 equals 27. So we have on the right side here, we have 27 over 36. On the left side, we have 28 over 36. 28 is greater than 27, so therefore 7/9 is greater. You can also use least common multiples to help add fractions. So we need to add fractions by having the same denominator. So we need to find the equivalent or common denominator of 9 and 4 again. What you already did was 36. So instead of adding 7/9 plus 3/4, we could add the ones with the same denominators. We could add 28 over 36 plus 27 over 36. 28 plus 27. You can do it over here if you need to. 15, carry your 1. So it's 55. And your denominator stays the same. So we have 55 over 36. Boys and girls, even though this is improper, it would still be accepted. However, you could change it to a mixed number. That is our lesson on least common multiple and greatest common factor. Before I let you go here, I want to show you one more time how to use prime factorization to find your least common multiple. Let's break down 9. And 9 would be 3 and 3, which are both prime. Let's break down 4, which would be 2 and 2, which are both prime. Do these share any factors? And the answer is no, they don't share any factors. So to find the least common multiple, you have to take 9 times 2 times 2. Well, 9 times 2 times 2, same thing as 9 times 4, because the commutative property, and 9 times 4 equals 36. So the least common multiple of 9 and 4 is 36. And you can also do the other way. You can take 4 times 3 times 3,